Hello everyone. Now we are going to look into a theorem which can be taken as a problem sum, wherein we are trying to prove that the angle between the two tangents drawn from an external point to the circle is supplementary to the angle subtended by the line segment joining the points of the contact. Means we have already done this in theorem number 3, where we are saying that APO, that is the angle incline, the tangents incline equally to the line segment joining OP. That means this angle was equal to this, which we proved, and also we have proved this angle is equal to this. Now what we have to prove is AOB and APB are supplementary to each other. Means when you add up, it is 180. So we'll start with the proof by saying that we are going to take angle sum property for one of the triangle, and then we'll double it because we know that these two parts are equal and these two parts are equal. Okay, so we'll say in triangle PAO, angle PAO is 90 because it is the radius, right? Which OA is perpendicular to, or OA is a radius, so it's making 90° with the tangent. That is the theorem which we know, right? Now we are going to apply the next one, that is angle sum property. So by angle sum property, so we are saying OPA plus POA plus PAO is equals to 180, the three angles of this triangle. Okay, now we know this is 90, so we are going to say OPA, sorry, wrong name, yeah, OPA plus POA plus 90 is equal to 180. So can we say that POPA plus POA is equal to 90, because the 90 goes to the other side. Now we are doubling it, means multiplying 2 throughout. So 2 times OPA plus 2 times POA is equals to 180, right? I'm going to write it on the right side because we need the diagram next to each other. So let's open 2 times of OPA as OPA plus OPA, and 2 times of POA as POA plus POA, and that is equals to 180. Now if you look at the figure again, OPA is equal to OPB, which we know that, and same way POA is equal to POB. So one of the OPA I'm changing into OPB, and one of the POA I'm changing into POB. So what is happening here? We are ending up getting OPA plus OPB plus POA plus POB, right? We're getting the complete angle AOB and APB. So what is happening? OPA and OPB, when you add, it's the complete angle APB. Same way POA and POB, when you add, you get the complete angle AOB, right? So that means we'll directly say this is nothing but APB. And what is this? These two angles add up to be, yes, AOB, which is equals to 180. So thus the angles at the center and the angles at the extreme external point, tangent point, add up to be 180. Correct? This is the theorem that we have proved. Now we are going to use this logic to find the angle. That means we are going to apply the theorem. Okay. So if you see this question, they are saying that the angle at the center is 110. Find the angle at the external tangent point. So we'll directly say that POQ plus angle PTQ is equal to 180 because they are supplementary. So 110 plus PTQ is equals to 180. So PTQ is 180 minus 110, which is a 70. And you just have to say the reason as supplementary because we have proved the theorem, right? Similarly, if I have the next question, say PA and PB are the tangents from point P to the circle C. which is inclined at 80 means the angles at the extremity, that is APB is 80. Fine, APOA, not AOB. So what we'll do, first we'll say APB plus AOB, that is 180 because supplementary, right? So we'll say 80 plus AOB is 180. So AOB is going to be 100 because 180 minus 80 is equals to 100. Now, can we say half of AOB is POA? Because if I join this line, correct? So I'll get that. So half of angle AOB is half of 100. Half of angle AOB I can write as POA, and that is 50. Right? Clear? Okay, let's go to the next one. Now here they are saying that show that the tangent lines which are formed at the end points of the diameter of a circle are parallel. So here AB is a diameter, and I have to show that RS or line L is parallel to M. AB is diameter, right? That means it's passing through the center, obviously. That means, can we say that OA is perpendicular to RS? Or can I say OAR is equals to 90 degree? Because RS is the tangent. Similarly, can I say OB is perpendicular to PQ? Because OB is again a tangent. So we are getting OBP is equals to 90. Let's mark it. Okay. This is 90 and this is 90. Now, if I add these two angles, is it supplementary? Yes. So, what we are going to write down here? We are going to say, sorry, OAR plus OBP is equal to 180, and they form co-interior angles. Okay, that means RS and PQ are the two lines between which AB is a transversal in such a way that these two angles, the interior angles on the same side of the transversal, add up to be 180. So the sum of the co-interior angles is 180. That means very clearly we can say that RS is parallel to PQ. That means L is parallel to M, right? Clear? We are using the rule of the diameter and saying that the radius is perpendicular. So 90-90 co-interior. When two angles are co-interior between two lines and a transversal, then the lines are going to be parallel, the converse. Okay. Let's go to the next one. It's just the opposite. It's just the converse of the previous theorem. Now, if they are saying the line segment joining the points of contact to the two parallel tangents passing through the center, that means we have to say that AB is a diameter. Just the opposite. Right. So what we are going to do is we are going to construct here. What are we going to construct? OC as a radius in such a way that OC is parallel to PQ. Correct? And in this case, it's OA is the transversal kind of a rule that we are going to consider. Okay, I'm not mentioning it, but we'll be writing it. Okay. So now we know that this angle is 90. Right? And I've already taken OC is parallel to AB. That means this will also be 90 by co-interior and sum of co-interior angles. Correct? Now, if this is a 90 degree, okay, similarly, I can prove this also as a 90. When can I say that the two angles at that is AOC and BOC are 90? When AB is a chord. Correct? And it's very clear that the line passing through the center is perpendicular to the radius also. That means it has to be a tangent. So I'm going to list out these statements. So as mentioned here, I'm taking OC is parallel to PQ, and we know that OA is a radius. We have to prove that if we are joining OA and OB, then AB is the diameter. That is what we have to prove. Okay, so we know that OA is a radius, therefore PAO is 90. Now I'm taking PAO plus OC sorry, AOC. That means this angle plus this angle as 180 because they are co-interior. So I end up having AOC as 180. Correct? Similarly, I can say that what COB or BOC is 180. Where is 90? Sorry, there was a mistake. AOC is 90. Similarly, we proved that BOC is 90. So if I add up AOC plus BOC, will I get a 180? Yes. Now, this can be only possible if AB is a chord. Okay. So I'm getting the two angles at point O to be 180, right? AOC and BOC are 180. That means we'll say that AB is a chord, okay, which is passing through the center. Why? Because we know that OA and OB, as OA and OB are radiuses. That thus we have proved that AB is a radius, sorry, diameter, right? So this will be the clear. So what are we trying to prove? That if two tangents are parallel to the circle, then the line joining the point of contact is a diameter, or at the end of the end points of the diameter, that is the extremities of the diameter, if two tangents are drawn, then they are parallel to each other, right? Next, concentric circle. So here if you see, OP is the radius for the smaller triangle, OA is the radius for the bigger triangle, right? So they are saying the chord is 24 centimeter larger, becomes a tangent to the smaller circle. So here AB is 24. At the same time, AB is the chord for the bigger circle. So OP is the line passing through the center of the circle and touching the chord. That means it is bisecting the chord. So this will be 12, right? And the radius of the smaller circle is 5, and this is 90. So here we'll say OP is perpendicular to AB. So OPA is 90, one part, and also AP is equals to PB because it's a perpendicular bisector. So in triangle OAP, we'll do Pythagoras theorem. That is OA square is equals to OP square plus PB square. PA square. So OA square we don't have, this is 5 square plus 12 square, sorry. That will give me a 25 plus 144, right? And that will give me a 13. Why? Because this is 169, so OA is 13. Again, what is the rule here? The chord of the bigger circle is the tangent from the smaller one. OA is the radius of the bigger circle and OP is the radius of the smaller circle. So OP is passing through the center of the circle. That means OP is a perpendicular bisector of this chord. That means the angle of OPA or APO sorry, is 90, and AB chord is bisected by OP. Therefore, AP equals to PB. That's what I've done. So at the end of the day, I'm able to prove that OPA is a right angled triangle. So I'm writing in triangle OPA, I'm applying Pythagoras theorem, I'm getting the radius OA. Similarly, the next triangle, we have a two concentric circle. Again, AB is the tangent for the smaller circle and AB is the chord for the bigger circle. The radius of the bigger circle is 5, the radius of the smaller circle is 3. Again, we have to say here, OP is the line which is passing through the center of the circle for the bigger circle and it's perpendicular to the chord AB. And it is also dividing or it is bisecting AB into two equal halves, that is AP and PB. Therefore, here triangle OPA is right angled. So we are saying that OPA is a right angled triangle, and by Pythagoras we'll say that OA square is equals to OP square plus PA square. And I'm leaving this for you to solve further to find AP. But are we going to stop with AP? No, we'll double AP because AP plus PB is same. So whatever AP you're going to get, double it to get your length of the chord. Am I clear? So what are we talking about? Concentric circle, where tangent of one circle is equal to the chord of the second circle. Hope it is clear. Thank you.